Okay, we are going to go ahead and start with the next lesson today, and I'm hoping you're going to find this pretty easy. It is very straightforward, but I'm going to walk you through the whole process. But before we go ahead and get into it and I start talking about everything, if you didn't turn in the unit circle project today, if you can get it to me before I take off today, it is not going to be counted late. Please, it does have to be in by Thursday. In fact, by Thursday morning, anything outstanding, if you're wanting to retake, say, last week's test, or if you still had a homework assignment to turn in, or if you wanted to correct a homework assignment, any of those materials by Thursday morning, 8:05, is going to be that deadline to do so. So you still have a couple of days. All right, if you need help, come on to see me. At the end of the week, we're going to finish up with our district assessment. I know everybody's really excited about that. We'll start it on Thursday and then finish it Friday. And then, we'll just keep going as far as we can. We're 2/3 through the first semester. Okay, this Friday is the end of the 6 weeks. Okay. Well, we've been talking a lot lately about right triangles, and we're going to go ahead and kind of shift our focus for this next lesson. We are still going to be dealing with right triangles, as we go through our trig section, but for this lesson, we're not going to be looking at right triangles. We're going to be looking at what's called oblique triangles. There we go. Oblique triangles. So an oblique triangle, we're just talking about one that does not have a 90-degree angle. It's not a right triangle. So that means all three of your angles are either going to be acute, so they're smaller than 90, or you're going to have one what? One obtuse and then two acute. Okay. Thank you very much, sir. Appreciate that. All right. Oh, yeah, sure. Absolutely. Got plenty of copies up here. Would you pass that over to Andrew, please? Thank you. All right, and before I go ahead and get to it, we're going to be dealing with a lot of these diagrams. They're going to follow the same idea. Back in geometry, hopefully you were shown a capital letter is going to denote an angle measure. So we have angles A, B, and C. Those represent the vertices of the triangle. But we use a lowercase letter to represent the side length. And you'll notice we're always going to match these up. So the side across from angle A would be side A. Side B is always going to be across from angle B, and so forth. Well, what if we still want to go ahead and find out all the information with regard to a triangle, but it's not a right triangle? So I can't immediately just go ahead and use the right trigonometry as we've been using. Well, that's where the law of sines and the law of cosines are going to come in. Okay, the law of sines is just a proportion. It says the sine of angle A divided by side A equals the sine of angle B divided by side B equals the sine of angle C divided by side C. Now, in order to use the law of sines, you have to have what I call a pair. A pair means you have to have an angle measure and you have to know the side length directly across from. Okay, well, let's get right to an example and see what you think. First example. It says solve triangle LMN. Now, when you're given an instruction and all it says is solve the triangle, what that's really trying to tell you is find every missing angle measure, find every missing side length. Okay, that's what it wants. So round side lengths to the nearest tenth and angle measures to the nearest degree. Okay, well, here we have triangle LMN. Okay, we don't know what N is and we don't know what side N or side M is. Well, without even using the law of sines, I mean, what's one thing I could easily find?
The side of L.
What's that?
The side of L. The little L.
The side of L.
Well, because, you see how, across from L is, the lowercase L?
Yeah, so that would be 22?
Yeah, so, my bad,
Find the other
Okay.
angle.
There you go. Antonio says find the other angle. Because every time you're dealing with the triangle, if you add all three angles, you should get what? 180. Yeah. So all I got to do to find that missing angle is just subtract 112 and 29, both from that. Okay, so I'm going to go ahead and write that out. 180 minus 112 minus 29. What's that going to give me? 39. Okay, so sometimes you don't even have to do anything fancy to find that missing angle. If you've already got 2, just subtract what you have from 180. Very easy. Now, here's what I'm referring to when I say a pair. In order to use the law of sines, you have to have an angle measure. Well, we have all three, and you have to have a side length across from one of those. So here, I have a pair when it comes to angle L. See, I have 29 degrees, but I also have the side length across from it. That's going to set up my first fraction. So I'm going to go ahead and say the sine of 29 degrees over the side across from it, 22, equals. And I'm going to go ahead and set up the same fraction, but for one of the other side lengths. Okay. And it really doesn't matter. Do you want to go ahead and solve for n or m first? M, okay. So if I want to go ahead and solve for m, then I have to use the angle across from it, the 112. So I'm going to have to say sine of 112 degrees over m. The law of sines is just a proportion. You just plug in. Now, how do you solve a proportion? Yeah, you just cross multiply, right? So I'm going to multiply here. So that would be m times the sine of 29 degrees is equal to, multiply, 22 times the sine of 112. Well, how am I going to get m by himself? Yeah, just like you can divide by a number, you can divide by a trig function. There's nothing wrong with that. So I'm going to divide both sides by the sine of 29 degrees. Sine of 29 degrees. See, those are going to cancel. Now I've got m equals. All I got to do is plug that in the calculator. I'm going to know exactly what that side length is. Now, before I do so, is everybody okay with what I did? Does anybody have any questions? I'm hoping you're going to like this lesson because a lot of really what's happening is you're just plugging expressions in the calculator. So let's see. I got 22 sine of 112. Let me come back over here. Document B. So control divide. 22. Remember your trig function's right here next to 7. Okay, so sine. It was 112. Oop, not 1,112. Divided by, what was it, sine of 39? Oh, 29, excuse me. Okay. Would everybody agree? And then as soon as I push enter, okay. Wait, did I get something wrong? Got it right? No, I'm good. 22 sine of 112. Yeah. Okay. So I think it said round the side lengths to the nearest tenth. So let's say m is about 42.1 units long. Whether that's feet, inches, we have no idea, but 42.1 units long. There you go. And then now I want to go ahead and just find the last side in. Now here's a big question that came up a lot with the pre-cal IS students. Can I use the Pythagorean theorem?
Yes. If it's not too right.
There you go. We do have two sides of the triangle, but I can't use the Pythagorean theorem because it's not a right triangle. He only applies if it's a 90-degree angle. So here, I'm going to have to use the law of sines one more time to help me out. Now, what I like to do, I go ahead and stick with the original pair that I started the problem with. So I'm going to go ahead and say sine of 29 over the 22. But what am I going to set it equal to this time if I want lowercase n? Yeah, sine of 39 over n. There you go. That's the law of sines. Now I just cross multiply. So this would be n times the sine of 29 equals 22 times the sine of 39. Is everybody okay with my cross multiply? Okay. Now how do I solve for n? Oh, subtract? Divide. There we go. So I want to divide by the sine of 29 degrees. Okay, those cancel. That expression is going to give me the length for n. Okay. All right. So let's see what that gives me. So control divide, 22. Oop, there we go. 22 sine, what was it, 39? Over sine of 29? Is that all right? Okay, so as soon as I push enter, what should I be getting for the length of n? Okay. Nathan is absolutely right. I'd say 28.6. Okay. So 28.6. So we found everything there is to know about this triangle. That's it. We're just looking at oblique triangles, which means they have no right angle. Okay. So if they have no right, that probably means they're wrong. No? Nothing? I thought that was a pretty acute joke. Acute. Hey, look, math. Okay. Let's move on. Tough crap. All right, so let's do the same thing. Solve triangle XYZ. All right. So let me ask you a question. Am I even able to use the law of sines? Do I have a pair? Yes. I have an angle measure with x, and I have the side length directly opposite it. So I can use the law of sines. There's no problem. Now, what would you say the first item for me to find is? Yeah, if you've got two angles, I just go ahead and find the third one pretty easy. So somebody help me out. What's a 64 plus 41? Oh, 105. So what's 180 minus 105? Okay, so angle Y should be 75 degrees. Okay. Now I'm going to start with that pair. So sine of 64 over the side opposite 11 equals, well, now it just depends on what we want to solve for next. Brett, do you like Y or Z? Why? Well, because we got to solve the problem. Here's a why. I'm on fire today. Okay. So if I want to solve for Y, then I'm going to go ahead and say sine of 75 over Y. Would everybody agree? All right. So once again, is everybody okay with setting it up in the formula? Okay. Now we cross multiply. So this would be Y, that's a sine of 64 degrees, is equal to 11 times the sine of 75 degrees. And what would I do to solve for Y? Okay, divide through. So sine of 64 degrees, sine of 64 degrees. Those cancel. So that expression should give me the length of Y. Okay, so let's see what we get. Come on back over here. Okay, hold on. Document B. Okay, there we go. So control divide, and I totally forgot what my numbers were. 11 sine of 75. 11 sine of 75 over, what was it, sine of 64? Is that right? Okay. So how long is side Y? I'd say 11.8. Okay. All right. 11.8. Is anybody having trouble with the law of sines? Anybody confused by anything? Okay. All right, for this last one, I'm just going to use Pythagorean theorem. Why not? It's not a right triangle. Only if it's a right triangle can I use the Pythagorean theorem. So I'm going to go back once more to the law of sines. I'm going to stick again with the original pair. Sine of 64 degrees over the 11 equals, what should I set this equal to if I want Z? Sine of 41 degrees over Z. There we go. Now, once we have the proportion created, then we can cross multiply. All right. So this would be Z times the sine of 64 degrees equals the other product, 11 times the sine of 41. Well, once again, we'll divide through by the sine of 64. Sine of 64. Those are going to cancel. So somebody help me out. If you were to type this in the calculator, what should we get? Yeah, it's like 8.0 something, right? So we'll just go ahead and say 8. And there you go. And remember, there's some ideas that are going to really help us out as we go through. The longest side should always be across from what? The largest or the smallest angle? Okay. The longest side should always be across from the largest angle. Is that what we're seeing here? Yeah, 11.8 is definitely across from the largest 75. So by the same idea, the shortest side should be across from what? The smallest angle. And see, 8 is across from the smallest angle, 41. Okay, so you're going to see that idea, come up quite a bit in these problems. All right, so for right now, let's go ahead and skip this one. I do like this problem, but I don't want to go ahead and try to rush it with the time we have left. Let's do this one. A tree is leaning 10 degrees past the vertical, as shown in the figure. A wire that makes a 42-degree angle with the ground 10 feet from the base of the tree is attached to the top. How tall is the tree? Okay. So let me go ahead. Let's say 2 minutes. Based on what we've seen so far in these problems, try to find the height of the tree. Let's go ahead and round it to the nearest foot. Okay, to the nearest foot. So hopefully this problem doesn't stump anybody. Okay. Hopefully you won't feel that law of sines and cosines bark is worse than its bite. It's a tree problem. Okay. Just trying some new material with you guys. You could say I'm branching out. I feel if I stick with it long enough, I'll get a laugh. Oh, mercy me. Okay, so that is your 2 minutes, and you may not be done. That's okay. So let me go ahead and highlight the triangle we're talking about here. Okay. So what is it we're actually trying to find? The height of the tree. So let's say that's my unknown. You can label it, whatever you want. So do I have enough information to go ahead and find it yet? Okay. So where's my pair? There we go. We got to find that third angle. So 100 plus 42 is 142. So what's 180 minus 142? 38. So this missing angle right here should be 38 degrees. Okay, so walk me through. What should I write down? Okay, so sine of 38 degrees over 10. Okay, that's my pair. Sine of 42 over x or a, whatever it is you want to call it. Did everybody set it up correctly? Okay. Now, just like before, we cross multiply. So let's see, that's going to be x times the sine of 38 degrees equals 10 times the sine of 42 degrees. What now? Okay, so divide through by that. Sine of 38 degrees, sine of 38 degrees. Those are going to cancel. So as soon as you plug that in the calculator, we should know the height of the tree. There you go. When you round it to the nearest foot, you're getting about 11. There you go. Questions? Is anybody having a hard time? How many people got that one right? Okay, good, good, good. Now, you might also get to the point where you don't have to show the two products equaling each other and then dividing. If you get comfortable enough, you might be able to just jump to the expression you're needing to plug in the calculator. If you already feel you're to that point, fantastic. Again, I just want to make sure everybody's on the same page. Okay, well, let me go ahead and at least just show you this before you take off. We won't actually work a problem just yet. I just want to go ahead and show you the formulas, and then we'll go ahead and continue this tomorrow. Now, what if you want to do the same thing for a triangle? We're still dealing with an oblique triangle. What does that mean? It's not right. That means there's no right angle. Okay, but I want to go ahead and figure out, the same thing. I want all the missing side lengths. I want to know all the angle measures, but I don't have a pair. I can still solve the problem if I go ahead and use what's called the law of cosines. Okay, now you don't need a pair. In fact, you just need two sides and possibly an angle or all three sides. So you'll notice there's three different formulas here, but they all follow the same pattern. You always start with one of your three side lengths. Okay? So you'll notice if you start with side A, what are you ending with? You're ending with the angle across from side A, cosine of A. If you start with side B, you're going to finish with cosine of angle B. Okay? Same thing for C. Now there's also a pattern to the other two sides that you're not starting with. Okay? Whatever you start with, let's say you start with A, you'll notice the other two sides, B and C, you're going to square them, add them, then minus 2BC cosine A. Well, what happens if you start with B? What are the other two sides? A and C, you do the exact same thing. So A and C are both squared, we add them, minus 2AC cosine B. Or if you start with C, you do the same thing to both A and B. So it doesn't matter, and the one thing I want to go ahead and emphasize, you're not going to have every triangle labeled as ABC as long as you follow the pattern. Okay? So I'll tell you what, we'll go ahead and stop there, and then tomorrow we'll come back, we'll do our first example. Okay? All right. So good. If I can get you to put your calculators back up on the front charging station, please.